Hello everyone, here is a brilliant problem on the board. Each resistor present in this circuit has the resistance equal to 4 ohm and each battery has the EMF equal to 4 volt. All these batteries are ideal. Then we need to find current through this resistor. I request you to pause the video here and give it a try, then I'll be simplifying it. I hope you are done with your calculation and the correct answer is 2 ampere. The current through this resistor R is 2 amperes. This answer can be obtained quickly using the KVL, and for KVL we have to choose such a loop in which there are the ideal batteries and this resistor only. See how to do it. Suppose we start here and then we go along this path. Just pay attention. Like this, we traverse here and then we go along this path like this and then reach back to the same point. See the advantage of choosing this as a loop for applying KVL. We know EMF of all the ideal batteries. We know the value of resistor R, then only unknown is this current I. So applying the KVL will be very easy. I am writing the potential difference here with the proper sign. Now, in this blue loop, I am applying KVL. Pay attention. Starting here, I'll choose the last sign which is plus 4. So potential drop here is plus 4. Then going along this path and then coming here. Last sign is minus, so this is minus 4. Then going down, potential drop across the resistor will be equal to I into R, and the value of this resistance is also 4 ohm. And current in a resistor is always from high potential to low potential. So this IR will have these sign, high potential here and low potential here. So the final sign here I am taking as negative. Then going further along this path and then this is plus 4. Going further along this path, this is plus 4 and then reaching back to the same point. Then it must be equal to 0. Simplifying this equation will get this unknown I, which is equal to 2 ampere. Okay, the brilliant solution. You note it down, then I'll present the detailed analysis of this circuit. Now we will see the detailed analysis of this circuit. So here I am assuming the potential to be 0 volt. Then this should also be 0 volt because here is no resistance, so no potential drop. This should also be 0 volt. This should also be 0 volt. Do you agree? Going up here, this must be 0 volt, this must be 0 volt, and this must also be 0 volt. It should also be 0 volt, here also be 0 volt. But now here is a resistance. There could be a potential drop across the resistor. So here we have to find the potential. If this is 0 volt, then potential of this point should be 4 volt. If we have a battery of 4 volt, practically it means what? The high potential minus low potential should give us 4 volt. So if this is 4 volt and this is 0 volt, high potential minus low potential should give you this potential difference. Okay. Now what else we can write? If this is 0, then this should also be 4 volt as shown here. If this is 4 volt, then this must be 4 volt because here is no resistance, so no potential drop, and here should also be 4 volt. Do you agree? Now, if this is 4 volt, then this should be 8 volt. How? Pay attention. If we need a battery having the potential difference of 4 volt, and if higher potential is 8 volt, lower potential is 4 volt. So higher potential minus lower potential, you'll get the potential difference of 4 volt. Okay. Now if this is 8 volt, here should also be 8 volt, this must be 8 volt, this must be 8 volt, because here is no resistance, no potential drop. This should also be 8 volt, this should also be 8 volt. Okay, then this should be 8 volt. Now can you tell how much should be the potential here? Simple, it should be 12 volt. I can explain that also. You need the potential difference of 4 volt, then high potential minus low potential, 12 volt minus 8 volt will give us 4 volt. If this is 12 volt, here is no resistance, means this should also be 12 volt, 12 volt, 12 volt, here also 12 volt. Okay, it's simple. Then this should also be 12 volt. If this is 12 volt, it means how much should be this potential? It should be 8 volt. And if this is 8 volt, this should be 8 volt. Here is no resistance, so no potential drop. Till here I can write 8 volt, and up to here I can write 8 volt. After that, here is a resistance. I think we have written the potential of all the points. As we know the potential, we can easily find the current. Suppose we have a resistor, and in this resistor we need the current. This point is at a potential VH, this point is at a potential VL. Then what will be I? The I will be equal to V high minus V low divided by R. R is the resistance. Okay, so I am doing the calculations. I missed the potential of this point, it should be 12 volt. Now we are writing the current, 12 volt minus 8 volt. So how much is the potential drop here? 12 volt minus 8 volt is 4 volt. 4 volt divided by 4 ohm, it means current here should be equal to 1 ampere. I am using this formula. High potential is 12 volt. Low potential across this resistor is 8 volt. 12 minus 8 divided by resistance is of 4 ohm. So 12 minus 8 by 4. The answer will come out to be 1 ampere. Okay. Now let us look at this resistor. Here is the potential drop of 8 volt, and this is the potential drop of 0 volt. So 8 minus 0 by 4 means the current through this resistor should be how much? 2 ampere. Okay, and for this resistor there is no current. For this resistor there is no current. It is actually short circuited path, so the current will pass like this across this part of the circuit. There will not be any current here. Okay, now we can write for this resistance, high potential is 8 volt, low potential is 4 volt. So 8 minus 4 by 4 means this current should be equal to 1 ampere. Is it okay? Now going further, for this resistance, high potential is 8 volt, low potential is 0 volt. So 8 minus 0 by 4, this current here should be 2 ampere. Fine. Then current through this 4 ohm resistor should be 0 ampere. There should not be any current, because this is at 8 volt and this is also at 8 volt. The potential difference is 0. If VH and VL both are equal to 8 volt, then current through that resistor will be 0. Now we can write for this resistor. Here the potential is 8 volt, and this potential should be equal to actually minus 4 volt, because for the battery high potential is 0 volt, then 0 volt minus of minus 4 volt will give us this potential difference. Now we need this current. Current through the resistor is always high potential minus low potential divided by the resistance. So for this resistor, high potential is 8, low potential is minus 4. So what you will write? 8 minus 4 divided by that resistance. So this current comes out to be 3 ampere. Okay. Going further, for this resistor there should not be any current, 0 volt, 0 volt. So short circuited path, and you can see the current will pass actually like this along this path. So for this resistor I was talking, there is no current. Here is 0 ampere, no current. Okay. Now look at this resistance. Here the potential drop is 4 volt and here the potential drop is 0 volt. So high potential minus low potential, there will be a current of 1 ampere. Then looking for this resistance, here should also be the current of 1 ampere. 4 minus 0 by 4 results into 1 ampere. Looking for this resistance, 8 minus 4 divided by 4. So this current should also be 1 ampere. Okay. Look at this resistor. 8 volt is the high potential, 4 volt is the low potential. So current through this resistor should also be 1 ampere. Then looking at this resistor, 12 volt, 8 volt, high potential is 12, low potential is 8. So 12 minus 8 by 4 means 4 by 4, current here will be 1 ampere. Look at this battery, the high potential is 12 volt, it means the low potential should be 8 volt, because 12 volt minus 8 volt will give us this potential difference. So for this resistor, there is no current in this resistor. Okay, 0 ampere means there is no current. Fine. Now looking for this resistance. Here the high potential is 12 volt, low potential is 8 volt. So current through this resistor will be actually 1 ampere. Current through this resistor will be 1 ampere. Current through this resistor will also be 1 ampere. Now if we look into this branch of the circuit, the current here must be 1 ampere. Reason, for this junction, this incoming current is 1 ampere. Current in this branch is 0. Total incoming current should be equal to the outgoing current. The current in this branch is 2 ampere. For that, let us check this junction. This incoming is 1 ampere means the incoming from here should also be 1 ampere. Then 1 ampere plus 1 ampere will make it 2 ampere. Is it okay? Now look at this junction. The incoming current here is 1 ampere and here this current is 2 ampere. It means from this branch the current should be 1 ampere. Check it once. For this junction the incoming is 1 ampere plus 1 ampere, 2 ampere, and the outgoing is also 2 ampere. So everything is fine here. Now checking for this junction. For this junction the outgoing here is 1 ampere and this outgoing is 1 ampere. It means this current must be 2 ampere. Do you agree? Now for this junction, if we apply the Kirchhoff's current law again, this outgoing is 1 ampere, this outgoing is 2 ampere. It means how much should be the incoming for this junction? It should be actually 3 ampere. Do you agree? It means 3 ampere current is entering into the positive terminal of this battery. This battery is actually getting charged. Okay. C is indicating for charging. Fine. Okay. So we know the current here, we know the current here, here. In all these branches, we know the current. It means we can find the current here. How? Pay attention. This current is 1 ampere plus this current is 1 ampere, 2 ampere, then 3 ampere, then 4 ampere, then 7 ampere, and this 1 ampere means 8 ampere. It means the total current in this branch is 8 ampere. So for this battery, the outgoing current is 8 ampere. From positive terminal, the current is leaving. It means this battery is getting discharged. If from the positive terminal 8 ampere current is leaving, then in the negative terminal the same 8 ampere current should enter by the conservation of the charge. Out of 8 ampere, 1 ampere is distributed here. So in this branch the current must be 7 ampere. Out of 7 ampere, again next 1 ampere is distributed here. So in this branch the current is 6 ampere. Out of 6 ampere, we send the 2 ampere current here. So the remaining current in this branch should be equal to 4 ampere. Out of 4 ampere, the 3 ampere is here. So this branch will have the current 1 ampere. For this junction, the incoming is 1 ampere. So the outgoing should also be 1 ampere. Is it okay? Let us go further. Now look at this wire. The 2 ampere current is here, and for this junction there is no outgoing here. So this 2 ampere current should be here. Okay, this is incoming for the junction, the 2 ampere current, and the outgoing should also be 2 ampere. For this resistor, the current is 1 ampere. This 1 ampere current enters into the positive terminal of the 4 volt battery. It means this 4 volt battery is also getting charged. Okay, this 1 ampere current reaches here, this 2 ampere current reaches here. So the current here should be equal to 3 ampere. Check for this junction. Total incoming current is 1 ampere plus 2 ampere. Total outgoing current should also be 3 ampere. Let's do few calculation here also. This is 4 volt, this is 0 volt. So how much should be the current here? It should be 1 ampere. So for this junction, if we check, this incoming is 3 ampere, this is 1 ampere. So the outgoing should be 4 ampere. There is no current in this. It means this 4 ampere reaches here. Now you can easily justify the things about this junction. 3 ampere incoming, 2 ampere incoming, 4 ampere incoming. Total incoming for this junction is 9 ampere. So the total outgoing should also be 9 ampere. There is no current in this resistor. We already know. Okay. It means for this junction, the outgoing here should also be 9 ampere. Incoming is 9 ampere. Outgoing should also be 9 ampere. There is no current in this. This 9 ampere should reach here because there is no current in this resistor. So for this junction, incoming should be equal to outgoing current. Now look at this junction. This 9 ampere and this 1 ampere, they are incoming current for this junction. So this should be equal to 10 ampere. Do you agree? Now looking here, this 1 ampere current is the incoming current. So the outgoing current should also be 1 ampere. It means here also you are getting that 1 ampere current. For this junction, 1 ampere plus 10 ampere. It means the outgoing here should be 11 ampere. This battery is getting discharged. Okay. The current here is leaving the positive terminal of the battery and entering into the negative terminal. Current here is 11 ampere. Fine. Now look at this junction. The current here at the incoming of this junction is 1 ampere, and the current here outgoing is also 1 ampere. Incoming equal to outgoing. It means the current in this branch should be 0. Here is no current. At this junction, 11 ampere incoming, 1 ampere incoming, and there is no current in this branch. So the total incoming for this junction is 12 ampere. That 12 ampere should be the outgoing. Okay. See it again. 1 ampere incoming, 11 ampere incoming, 0 ampere incoming. So incoming is 12 ampere. By conservation of the charge, the outgoing should also be 12 ampere. That 12 ampere reaches here at this junction, and we can see easily out of this 12 ampere, outgoing here is 1 ampere, outgoing here is 1 ampere. It means here the current should be 10 ampere. 10 ampere current is entering into the negative terminal of the battery. It means this battery is getting discharged. Okay. This 10 ampere current will leave the positive terminal of this battery, and the 10 ampere current will reach here. For this point, the outgoing is 8 ampere and this outgoing is 1 ampere. It means this incoming should be 9 ampere. Do you agree? Now focus on this junction. This outgoing is 9 ampere. This is 1 ampere. It means the current here should be 10 ampere. Do you agree? Okay. Now again focus on this junction. This incoming is 1 ampere and this outgoing is 10 ampere. Pay attention. Incoming is 1 ampere. This outgoing is 10 ampere. It means how much should be the incoming from here? Simple. It should be 9 ampere. Now check. 9 ampere plus 1 ampere will make it 10 ampere. Out of that 10 ampere, here is 9 ampere and here is the 1 ampere. Okay. Now for this 10 ampere, we know that here goes 9 ampere. It means here should be 1 ampere. There is no current in this branch, then here should also be 1 ampere. Now checking this junction, this incoming is 1 ampere, this incoming is 1 ampere, and outgoing here is 3 ampere. It means how much should be the current in this branch? It should be 1 ampere. Now check, 1 ampere plus 1 ampere plus 1 ampere. Total incoming is 3 ampere and the total outgoing is also 3 ampere. If I check this junction, then 1 ampere incoming and 1 ampere outgoing. So there should not be any current in this 4 ohm branch, that we already know. The current here was 0 ampere. I think we have figured out the current in every branch. Okay, and we can see which battery is getting charged, which battery is getting discharged. This battery is getting charged as current is entering into the positive terminal. This is getting charged because the current is entering into the positive terminal. This battery is getting discharged because the current is leaving the positive terminal of the battery. This battery is also getting discharged, this is getting discharged, this battery is getting discharged, and this battery is neither getting charged nor discharged because there is no current in this branch. Okay, it is an interesting insight about this beautiful problem. I request you to pause here and try it yourself. You'll surely enjoy it. Stay awesome. See you again.